Today we are going to start to talk about areas of figures. So the area is the amount of surface that a figure covers. And we always refer to those units as square units. So you can see I have a piece of graph paper and some figures drawn on them. And you can see the squares. We're going to count the number of squares. That's just one way we can find the area of a figure. So say we wanted to estimate the number of square units. So a square unit is a square, and it's whatever the distance or the length of one of those sides are. So if we say that we're talking in centimeters, it would be 1 centimeter on each side. So we say they're square centimeters. If they're feet, they're square feet. If it's a mile, then it's a square mile. So that's how we are going to refer to them. So on just graph paper here, I didn't label them, so we're just going to call them square units. So I have this kind of odd figure here. It might be a lake. I might want to find out, how many square miles is this lake? And say each square represented a square mile, so 1 by 1. What I first will do is I will count the number of full squares. I'm just going to put a mark on them just so that we know how many squares there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So there's 23, we'll just say 24 full squares. And then we got to count some of the partial squares and see how many of them they kind of sort of add up to a full square. So I would say maybe these right here add up to a square. There's 1. Maybe these 2 add up. There's 2. There's 3. And maybe all of these together is 4. Maybe all these together is 5. So maybe there's an extra 5. So we can say it's approximately 29 square miles. Okay, see how we put the square, the 2 where the exponent would go, square miles. That means it is a square, which is a mile on both sides. Okay. So that's just a way to estimate. Now, say we had this shape up here. We know from our last geometry unit that is a rectangle. It has 2 sets of parallel sides, and it has right angles. Every angle is a right angle. Okay, so we could do the same thing. We could count all of the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 48 units squared. Okay. That's a lot of counting. Just think if you had a larger shape. So there's got to be a better way. And I think you can figure it out that this kind of looks like the way you might have learned multiplication way back in 3rd grade. So we have rows. All of these rows are the same. And each row has 8 squares. So we learned back in the day that I have, let's see, each row has 8, and I have 1, 2, 3, 4, 5. 5 times 8 equals 40. That's an array. That's how we learn how to multiply. Now when we find the area, we have a special formula. A capital A represents area, and that equals length times width. Now remember, when we use a lowercase l, it's always a cursive L, just so that doesn't look like a 1. So the length is across, and the width is the other direction. So if our length is 8 and our width is 5, our area is 40 units squared. We can do the same thing with this rectangle. So instead of counting them, let's look. We have 1, 2, 3. Okay, our length is 3, and our width is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our area equals 3 times 11, which is 33 units squared. Now, what are we going to do with this one? It's a parallelogram. Okay, just like a rectangle is a parallelogram, it has two sets of parallel sides. Rectangles have 90-degree angles. That makes it kind of easy. Now, a parallelogram, they can have a slant to it. Okay. So, to help us out, we're going to try to find out what we should do. All right. I made a parallelogram here. I am going to do something to it. I am going to figure out, I'm going to draw a line here. And I made a 90-degree angle. So here is the height of my rectangle, or my width. Then I am going to take my scissors. I'm going to cut along that really carefully along this. Okay. So there's my parallelogram. And now I am going to take this triangle. I am going to just slide it over here and put it right up there. Oh my goodness, look what happened. That looks like it made a rectangle. Oh my goodness. All right, so now we know that when we have a rectangle, we can find its area by length times width. Okay. Now, in a parallelogram, we call this the base, and we call this the height. Base, height. Now, the height, when we moved this, that's the same as our width. Our base. Okay? So we can't really call it a length. Okay? Because what does that length mean? Like the length of this parallelogram goes from here to here. So we call this a base. But when we do this, our base turns into our length. So really, if we wanted to find the area of that parallelogram, we would multiply a base times a height. And the way we note that is area equals base times height. A equals BH. So in this particular parallelogram, my base, 1, 2, 3, 4, 5, 6, 7, 8. So I have 8. And then my height is going to be from one of these corners straight up or straight down. And that is 1, 2, 3, 4, 5. So if my base is 8 and my height is 5, 8 times 5 is 40 square units. Now look what happened there. Look what I did. We had a rectangle that was 5 by 8, okay, or 8 by 5. Look at this. We have a parallelogram with a base of 8 and a height of 5. So these two figures have the exact same square area. And that is how you find areas of rectangles and parallelograms.